Hi, welcome to the 4th Analytical Geometry tutorial. This tutorial is merely a recap of all of the work covered in the first 3 Analytical Geometry tutorials. So, in terms of what you need to know, you need to have gone through the first 3 Analytical Geometry tutorials and all of the accompanying exercises, and you also need to be familiar with your grade 10 work. I want you to have a go at the following exercise. Press pause on your DVD player, and when you return, we'll go through it together. The first one I gave you to do read P, Q and R are points on a set of axes. P is the point 6 and 7, Q is the point 1 and -2, and R is the point 3 and A. The first thing I asked you to do was to calculate the distance PQ. Now PQ is going to be given by the distance formula, or rather we can calculate it using the distance formula, which says that that will be y2 minus y1 squared plus x2 minus x1 squared, all in the square root. That's going to give us square root of y2 minus y1, which will be 7 minus -2, or 7 plus 2, squared is 81, plus x2 minus x1, 6 minus 1 is 5, squared is 25, which gives us square root of 106, and we can leave it in that form. That is the distance PQ. Now in the second part of that first question, I asked you to calculate the coordinates of A. In order to do that, we are going to have to look at the other bit of information I gave you, which said that PQ is equal to RP, or rather 3RP. PQ is equal to 3RP. Now PQ we know is square root of 106. PQ we know is 106 units. Keep in mind always to say units when we are working with analytical geometry. If we are looking for distances, we use units, unless we have been given units, for example centimeters or whatever. So PQ is equal to 106 units, is equal to 3 times RP. To get the distance RP, we're going to have to use again the distance formula. RP is going to be given by y2 minus y1, which is A minus 7 squared, plus x2 minus x1, which is 3 minus 6 squared. I can get rid of both square roots. First I've got to get rid of that 3 in front of that square root, so I'm going to make it 106 divided by 3. Then to get rid of that square root, I square both sides. If I square that side, it gets rid of the square root. What I do to one side, I do to the other. That means that A minus 7 squared plus 3 minus 6 is going to give me -3 squared is +9. +9 taken across will become -9. Root 106 squared is equal to 106. 3 squared is equal to 9. Get this to a common denominator so we can add and subtract. Instead of saying -9, I'm going to say -81 over 9, which is the same as -9. 106 minus 81 over 9 means that I can work it over a common denominator. 106 minus 81 is given as 25. That means that a minus 7 squared is equal to 25 over 9. To get rid of the squared, I square root that side. What I do to the one side, I do to the other. And remember, it can be positive or negative. That means that a minus 7 on its own is equal to positive or negative 5 over 3. A minus 7 is equal to plus or minus 5 over 3. That means that a is either equal to, take the 7 across, that will be make it positive 7. A is equal to 7 plus 5 over 3, or a is equal to 7 minus 5 over 3. 7 plus 5 over 3 is the same as saying 21 over 3 plus 5 over 3, which is 26 over 3. Or a is equal to 21 over 3 minus 5 over 3. 21 minus 5 is equal to 16 over 3. 26 over 3, we can simplify that if we want to. We can turn this into an improper fraction. 3 goes into 24 8 times. Our remainder is 2 over 3. Or at the bottom, 3 goes into 15 5 times with a remainder of 1 over 3. Our two possibilities of a are 8 and 2 over 3 or 5 and 1 over 3. What does that mean? That means that there are two possibilities that a can have in order for Rp to be a third of the length of PQ. Basically, the a value, remember, is our y value of R. 8 and 2 over 3 means that it's going to be a little bit higher than the p value, so it's going to be somewhere over there. Or the other alternative is that it's at 5 and 1 over 3, which is going to be a little bit lower, so it could be there or there. There are two possibilities. The second one I gave you to do had this graph over here, OABC, where OABC is a parallelogram. OABC being a parallelogram means that the lines OA and CB or BC are parallel, as well as OC being parallel to AB. I also said that OA is given by the equation y is equal to a negative a half x, and theta is equal to 45 degrees. The first thing I asked you to do was to give me the equation of CB. Now, in order to get the equation of CB, remember it's going to be a straight line in the form y is equal to mx plus c. Y is equal to mx plus c, that's the standard form of this equation CB. We need to start by looking for our gradient. We do not have 2 points in order to calculate our gradient from. However, we know that CB is parallel to OA, which means that the gradients have to be equal. The gradient of CB has to equal the gradient of OA, which is equal to negative 1 over 2. That means that the equation CB reads y is equal to negative 1 over 2x plus c. To calculate c, we substitute the point that we do have in, which is x is equal to negative 2, y is equal to 4. That means that 4 is equal to negative 1 over 2 multiplied by negative 2 plus c